Okay, in our previous videos, we were looking at, we were trying to predict variation in students' math achievement scores as a function of various level 1 and level 2 predictors. Um, the last video that I illustrated was of plotting simple slopes of the relationship between a level 1 predictor and a level 1 outcome, that being math achievement, um, across levels of a level 2 dichotomous predictor variable. So the variable that we incorporated was the variable public, and we were looking to see if the relationship between student level socioeconomic status and math achievement might vary across different types of schools, whether they be private school or public school. And so what we did was we utilized my Excel calculator to essentially generate those different slopes. We also found that in our previous analysis that the cross-level interaction between the um, level 2 predictor proportion of students intending to go to four-year college and SES, that interaction term was not statistically significant, nor was the interaction between student level socioeconomic status um, and the school mean for socioeconomic status. So SES, again, was the level 1 predictor. These variables right here are the level 2 predictors. But it's nevertheless kind of begs the question, what do you do if you happen to have a level 2 predictor that you could reasonably treat as continuous? And as I noted, just a second ago, that one of the calculators that I've worked up allows you to look at plotting simple slopes when you have a level 2 predictor that is dichotomous. But in this case, let's say I want to plot simple slopes at different levels of the level 2 predictor, um, and assuming that it is continuous. So I've actually worked up a little calculator for that as well. And let's see if I can find it. So here is an example of this calculator. It's basically plotting simple slopes with continuous IV and moderator. It's in the file graphing simple slopes in HLM with continuous X and Z mod variables. And so what I need to do is, it's really pretty easy to get the descriptive information like the means and standard deviations for the level 1 variable. The level 1 variable in SPSS, if I want to get that information, all I need to do is go to Analyze Descriptives, and I already showed you this in the previous video, but just move the level 1 variable over. The default is mean standard deviation, and so when you click on it, you'll see that you get the variable mean standard deviation, and you essentially just plug that information into, that's the previous one right there. So I'm just going to that, and then just plug that information in here. But the trick is the level 2 moderator variable, and you really don't want to compute the mean and standard deviation on the moderator across all cases in the data set. In this data set right here, we had essentially, looks like about 6,871 students that were distributed across 419 schools. And so the level 2 predictor, for instance, school level SES, I don't want to compute the means and standard deviations across all the students. I compute it across the schools. And so that gets a little tricky in cases where you have a data set by default that incorporates both the level 1 and level 2 information. A lot of times when running multi-level models, you'll have one data set that contains the level 1 variables, and then a second data set that would contain level 2 variables. And then perhaps a common variable between them that would allow you to merge the level 2 variables into the level 1 data set. But nevertheless, you would still have an original level 2 data file that you could essentially run the means and standard deviations on. So you'd have the 419 schools, for instance, with their respective means on this variable and also this variable and this variable. Um, and you could get the means and standard deviations for those. But in this illustration, I don't have that. The data set is coming from um, a data set that was provided at the publisher's website, and it was all nested within basically the level 2 and level 1 variables were all integrated already. So that raises the question of how do I look at the school level data and compute the school level, the average of the means across schools and the standard deviations of those means across schools for those predictor variables. So one strategy that I've kind of come up with is let's say I want to compute the mean and standard deviation of school level SES. So in other words, I want to take, you can see right here, I've got school 1, school 2, school 3 down here, and then the school mean is attributed to each of those students within the data set. But the mean for school 1 is negative 0.27, the mean for school 2 is 0.68, the mean for school 3 is negative 0.55. So if you're working in SPSS and you want to pull that information out, here's a suggestion. What you can do is take your predictor variable and essentially just generate a one-way ANOVA. All right, so I'm going to move school code to the fixed factors box, and I'm going to move SES mean, which is the aggregate mean SES level for the students in each school. I'm going to move that over here. Now, we don't care about the ANOVA. This is sort of a workaround to get some information at the school level. So I'm going to click on Options, and I'm going to move school code over here, and I want to display the means in the output file. So I'm not going to ask for anything else. I don't care about the ANOVA. I'm essentially kind of tricking SPSS to give me what I want. So I'm going to click on Continue and then on OK. And so now you've got output for the univariate ANOVA. And like I said, I don't really care about the ANOVA. I don't even care about the between effects or anything like that. What I care about are these means right here for each school. And you'll notice school 1, negative 0.267, school 2, the mean is 0.680, and so forth. So, if we go back to our original data set, I'll even add in a third decimal place so you can see it. There's a 267, 0.680, negative 0.548, all that stuff is what you see right here. So, what I'm going to do is to copy this information into an Excel file. And so the way I'm going to do this is I'm going to highlight the table. So you can see it's got the means for the school on the level 2 predictor, SES, all 419 schools. And what I'll do is I'm going to right click and then click on Copy Special. I'm going to only select Excel Worksheet. So I'm going to I'm going to have that button checked on, and then I'm going to click OK. And so now this table has been copied. And so next I'm going to go into a blank Excel spreadsheet, and then I'm just going to, you can see I'm up at A1 right here. I'm just going to press Control V, basically paste that information into the Excel spreadsheet, and then I can calculate the means and standard deviations pretty easily. So if I just type in equals average, and then I'm just going to highlight this column right here, and it goes a little bit further than what you can see on the screen. There it is down there, and hit enter. So there's the average SES across schools, or the average of average, I guess you could say, school SES mean across schools. And then I can do the same thing with the standard deviation. I'm going to take a quick side trip and just I'm going to copy that, and I'm just going to change this because I really hate highlighting. So I'm just going to say SD standard deviation, and then there you go. And so there's the standard deviation of the SES mean variable. So that's the standard deviation of this variable across the school. So now I have the information that I need to type in right here. And so that's the 0.019 that we had previously, and then the 0.486 is the standard deviation. And that's it right there. And then I just plugged in this information from the multi-level analysis. So kind of going back up and looking at our original table, the intercept was 56.506. I can find it here. Oops. There it is. And then the x variable is basically the same as from the previous video. It's just SES. So there it is right there. There's the regression coefficient. And then the moderator variable is the level 2 predictor, which is the SES mean, which is 2.697. So I just typed in the 2.967, and then the interaction term for the cross-level interaction. So it's this one right here, which is the negative 0.134, and that's typed in there. And so now you can see we've got the predicted values on Y at different levels of the level 1 predictor and the level 2 moderator. And so these are the regression slopes, and as you can see, they're pretty much parallel, which is what you would expect if there's no interaction that would be taking place across the levels. And so I basically did the same, utilized the same process when I was plotting out the simple slopes for SES at different levels of the level 2 predictor proportion, or the proportion of students intending to go to four-year college. So basically I just ran the one-way ANOVA, copied the table of school means out of the SPSS output, pasted it into the Excel file, and generated the mean and standard deviation, and then plugged those in along with the regression coefficients for SES, the intercept, of course, and then the proportion variable, which we have right here, which is 1.363, which is that right there, and then the interaction between the proportion, the level 2 predictor proportion, and SES, the level 1 predictor, which was negative 0.137, and so I rounded off at negative 1.38 right here. So that is essentially how I got that information. Also note, I mean, that if you were modeling, let's say you had two level 1 predictors, you could still use the calculator. You just wouldn't have to go through these steps to get any kind of level 2 variable means and standard deviations. All you need to do is just calculate the means and standard deviations using the descriptive options that I was telling you about previously. So that pretty well concludes this illustration.